In this video, we're going to look at a really common application of exponential decay, which is the amount of a medication left in your body after a certain amount of time. In this case specifically, we're going to be looking at the amount of insulin left in a patient who has diabetes after they receive 100 micrograms of insulin at the beginning. So we're given a graph here, which shows how much insulin is left in the patient's bloodstream, and then we're going to try to answer some questions with that. So the first question we are asked is that scientists have found the amount of insulin in a patient's body changes exponentially, which again means that we are multiplying by a constant factor each time we go from one step to the next. So to check this, we can check by looking to see, is there a constant factor? Or are we multiplying by something different each time? So they're actually going to help us with that in these next couple of questions here. Question 2 asks us, well, how much insulin broke down in the first minute, and what fraction of the original insulin is that? So in other words, what fraction did they lose in the first minute? So in this case, they went from 100 micrograms to 90 micrograms, which means they lost, not really lost, 10 micrograms broke down. And what fraction of the original is that? Well, 10 out of 100 is 1/10. How much insulin broke down in the second minute? Well, in the second minute, we went from 90 down to 81, which is going to be that 9 micrograms broke down. And they want to know, again, what fraction is that of the amount 1 minute earlier? So 1 minute earlier, there were 90 micrograms. So 9 out of 90 is, again, 1/10. So far it looks like this might be exponential, but let's keep going. What fraction of the insulin remains in the bloodstream for each minute that passes? So we can check one more here. If we go from 81 down to 72.9, that, if I pull out a calculator, is going to be a drop of 8.1 micrograms. And 8.1 out of the 81 that was there means that they again lost 1/10 of the insulin during that minute. So what fraction of the insulin remains in the bloodstream if we are going down by 1/10 each minute? That means that the amount that is remaining is 9/10. So that does seem to indicate that in this case, at least with the points we've checked so far, this is changing exponentially with a decay factor of 9/10. Or we're losing 1/10 of the insulin each minute, so 9/10 are remaining each minute. So we filled in all these values so far. Let's complete this table kind of using our rule that we used above. So if 9/10 remain from the previous minute, I'm going to do 72.9, and I'm going to multiply it by 9/10. So 72.9 times 9/10 is going to be 65.61. And if I do that again, times 9/10 after 5 minutes, there's going to be 59.05 micrograms of insulin. So we could keep going with this, right? I could do times 9/10 times 9/10 times 9/10, but we have a shortcut for doing this, right? We have, for repeated multiplication, we can use exponents. So if I want to find how many micrograms of insulin remain after 10 minutes, I can say, okay, well, the amount of insulin is going to equal, we started with 100, and we're going to multiply by 9/10 10 times. And that'll find how many micrograms of insulin are left after 10 minutes. And just because I'm curious, I'm going to go ahead and find that number. That number is 34.87 micrograms. We do the same thing for m minutes. If I want to go for m minutes, so in other words, I don't know how long it's been, so 100 times 9/10 with an exponent of m. So there are my two different equations that would find how much insulin is left after 10 minutes and how much insulin is left after m minutes.